We're now on to our final video of carbonyls, where we talk about the nucleophilic addition reactions of aldehydes and ketones. Now, that is going to involve reduction to form alcohols and also making hydroxy nitriles. And we'll go through the mechanisms and the equations in each example. Throughout this video, you can try and do them yourself. We do 2 examples of exam style kind of questions. And so the aldehyde usually first, then the ketone. So while you're looking at the video, try and listen to the aldehyde version and then try and do the ketone version on your own. And then I'll show you the answer. So the first thing is to show we do aldehydes, we do ketones, okay? And we're going to do reduction. So reduction can be thought of as adding of hydrogen as well as gain of electrons. So here we're adding hydrogen, which is how you remember it as reduction. Now we're using a reducing agent. The reducing agent is sodium tetrahydridoborate. So sodium tetrahydridoborate, this complicated molecule here, not really expected to remember it, but its name, as I said, is sodium tetrahydridoborate, and it's NaBH4. Now, what it does, it takes the aldehydes, and here is an aldehyde, okay, and takes that down to its alcohol. So the corresponding alcohol of an aldehyde is a primary alcohol because it's the terminal carbon turning into an OH, the last carbon. The next thing is a ketone. So the ketone, we're adding hydrogen to it and we're turning into that secondary alcohol. Now notice again, we are adding hydrogen as we go along. We'll explain that in a bit more detail in the next slide when we talk about the equations and the mechanisms. Now in the equations and mechanisms, you can represent this sodium tetrahydridoborate either as a H or a H minus. And we'll use the H in the equations and the H minus in the mechanisms. Now writing an equation for the reduction of aldehydes and ketones is using this H, as we've said. Now let's go through the aldehyde and then we'll go through the ketone next. The propanal becomes propan-1-ol using sodium tetrahydridoborate, aqueous. Okay, so if you're asked to do the conditions, you must put NaBH4 aqueous. And that reducing agent can be represented as a H. All you have to do is look at the difference between the product and the reactant. So if I draw the product, I know it's going to become a primary alcohol. So the primary alcohol has 3 carbons as well. And then if you look across, you can see, and I've coloured them in green here, you can see there's 2 green ones right there. You see there's 2 green H's been added. There are 2 green H's that have been added, okay, represent the number of H's you've used in terms of the reducing agent. So all I need to do is count the 2 H's and then my 2 comes in front of my H. Now that leads to our exam tip. Number of H's is equal to the number of hydrogens added to the final product. And therefore our 2 appears here in our balanced equation. And that's completely balanced. As I said, we're going to do the ketones. So the ketone becomes propan-2-ol. We've got NaBH4 aqueous again. And we've got our ketone. Now, as I said at the start of the video, can you complete it before I do? So we've got our H, and that turns into our secondary alcohol this time, so propan-2-ol. And again, we're going to colour our H's in green. You can see in the bottom right there, you can see the 2 H's that have been added coloured in green. You can see they're not there on the original. Okay, so that means 2 H's have been added, and that is how you do balanced equations for reducing aldehydes and ketones to alcohols, primary and secondary. Remember that, and now we're going to show you how this is nucleophilic addition. But if you want to do more practice on these, invent your own examples, put 2 aldehydes in something. Remember, if you have 2 aldehydes, you'll just need 4 H's. Okay, so try and practice those to get your skills up. I'm going to write the mechanism now. Okay, and reducing aldehydes and ketones has the same mechanism. So again, I can show you the first one and you can do the second one. And the NaBH4 is represented as H minus, and that's our nucleophile. So the H minus is a nucleophile, and if you remember the definition of that is donates a lone pair of electrons to form a dative covalent bond. Okay, so it needs a lone pair of electrons. Most of the time it has a negative as well, but it needs a lone pair of electrons. So let's look at our example of an aldehyde. So our aldehyde, let's do dipoles first. This is how I always do mechanisms. I put my dipoles on. That means I know where my electrons are going to and going from. Here is my nucleophile, and the nucleophile has got that lone pair of electrons on it. It's H minus. It's gained an electron from somewhere else to become that minus. Now what I do, once I've put my charges on, I've put my lone pairs on, I've done my dipoles. Remember, each one of these is going to get you a mark in the exam, so that will get you a mark. Okay. We're now going to take where the electrons are to the positive charge. Now when we do that, that really shows I'm moving 2 electrons to the C and I'm making a bond. I'm making a bond between the H and the C. If you then count the number of bonds, you've got 1, 2, 3, 4, 5. That's too many bonds for a carbon. So I need to get rid of one. The best way of getting rid of one is to take the electrons out of a bond and place it onto one of the atoms. That's usually an electronegative atom. So the electronegative atom here is oxygen. So let's take the electrons out of that bond and put them onto the oxygen atom. That means one of the electrons from the carbon is going onto the oxygen and one of the electrons from the oxygen is going onto the oxygen. If that's the case, the oxygen has an extra electron. So that then turns into this O minus. So because it has an extra electron, it's got O minus. So here, it then reacts with water. So I've got water here. First rule, as I did over there, I'm going to put my dipoles on. Okay, there are my dipoles. I know where my charge is, I know where my electrons are, they're down here. I'm going to take my electrons up to my positive charge. There's too many bonds to the H, and therefore I must break it, because there's now 1, 2 bonds to the H. Okay, you can only have 1 bond to a H. So I'm taking the electrons out and putting it on the oxygen just like I did here. That means I then turn it into an alcohol, and you can see turned into an alcohol, and then what remains here is an OH minus. We then go to the ketone. So the ketone here, we're again representing our nucleophile, because this is nucleophilic addition. Remember, you're adding hydrogen, so it's addition. It's a nucleophile, so it's nucleophilic addition type of mechanism. The reaction type is reduction, but the type of mechanism is nucleophilic addition. So this time, slightly different. I'm going to take the arrow. I'm going to take it from the lone pair, because you can take it from the lone pair or the minus. But before I do that, let's do our dipoles. So our dipoles are done because oxygen is more electronegative. I'm going to take it from my negative here, okay, and put it on to my carbon. Remember, you can do it from your lone pair of electrons. Now, from there, we're going to break that bond out again because the C has too many bonds, and we break it out. And then we create our O minus. Now from the O minus, we're still going to react it with our water. So here's our water here. I'm going to take our dipoles and our negative to our positive charge. Too many bonds between the H and the O, so that's going to break. And then we end up making our secondary alcohol and our OH again. So this is our 2 examples of nucleophilic addition using the H minus as a nucleophile. Remember, you can do it from the minus or you can do it from the lone pair electrons. Over here, I've done it from the lone pair of electrons, not the minus. Okay, over here, I've done it the minus. It doesn't matter which one you do. Do the minus or do the lone pair of electrons when you're doing this. But practice this. Sometimes, again, put 2 aldehydes in, for example, or, you know, put 2 ketones in. Practice it many times. Make sure you do this, because this is a 3 to 4 mark question in an exam, and is more than likely to come up. At least 1 or 2 mechanisms come up per exam that you sit. One of the most important reactions is carbon chain lengthening style reactions, which are nucleophilic addition. So this is done using HCN essentially, but when you're in the exam, these are the conditions that you want to report to if you're asked for the reagents or the reactants for this type of reaction, NaCN/H+. Now they form hydroxynitriles, and they form them from aldehydes and ketones. Now our aldehyde we're going to do is propanal. That becomes 2-hydroxypropane nitrile. Again, don't worry too much about the naming of that. Okay, and you're going to use NaCN and H+. As I said, again, that goes in your reactants when you're doing the exam. And it creates this CN- nucleophile. Now this CN- nucleophile, it is nucleophilic addition when it reacts with the aldehydes. So again, here's your aldehyde. Why don't you try and do the mechanism without me? Now the C here is where your CN is going to bond. So your CN is going to bond there and it's going to create this alcohol. So we're adding the CN and essentially we're adding the H, and that means that's that nucleophilic addition again. The CN is adding and the H is adding there, and that creates our hydroxy propane nitrile that is there. We then take the propanone and that can become 2-hydroxy 2-methyl propane nitrile again, don't worry about the name, and that's with the NaCNH plus aqueous and the CN minus nucleophile. This time the ketone here is going to turn into this hydroxy nitrile there with the CN where the carbonyl is. So you're looking for where the carbonyl is, and that's where you're putting the CN on. This will make more sense when we look at the mechanism where you react these aldehydes and ketones with the CN minus nucleophile through nucleophilic addition. So here we have our aldehyde, and we do the same process. We're going to put on our dipoles. We have our nucleophile, and remember the arrow can come from the minus or the lone pair of electrons. In this case, we're going to take it from the minus to the delta plus, and again, too many bonds to the carbon, and it's going to go out again. That means we create a negative oxygen, which is our intermediate here. And there's a slight difference with this reaction, is that you can react it with water in this example, but we'll show you a slightly different example underneath. So again, we put our dipoles on and then take our minus out to our H, our dipole, our positive. Too many bonds to the H again, so one breaks and goes back into the electronegative element. And that creates our hydroxy nitrile. Now we're going to do another example. And this example here is the ketone. So we start off again with our nucleophile, and again our dipoles, plus and our minus. This time we're going to take it from our lone pair. Like I said, doesn't matter, minus or lone pair. Okay, and then too many bonds again, comes out again. You notice a real theme that's happening here. This theme, arrow in, arrow out. Okay, then we go to our intermediate, and we've got our negative charge here, and this is where I said we're going to do it slightly differently here. So you can do it with H+, because it is NaCN and H+, that means the H+ is aqueous, so there's water around, but it's H+, which means there is acid around, so it can react with acid as well. And that's even simpler, because you can just take the negative or the lone pair out to the H and bond with it, and that creates your alcohol. So we've got our alcohol here, and that is how we add length to the chain. So what I want to just quickly go over is, look, 1, 2, 3, 4 carbons in length. It was 3 carbons in length. 1, 2, 3 again, and we've got 1, 2, 3, and again we've got a branch here. So it's a way of introducing branching as well, which will become more important when we're talking about synthesis and everything like that. But again, you're lengthening the carbon chain. So a little hint and tip, if you are doing any synthesis within exams, and suddenly they're asking you to say what happens or what reagents you use when it goes from, I don't know, 3 carbons to 4 carbons. Well, as soon as you see an extra carbon, you know it's one of these carbon chain lengthening reactions. And there are only 2 carbon chain lengthening reactions. One is with aldehydes and ketones, and one is with haloalkanes, which we'll talk about in another video.